Hello and welcome to another one of these ADD videos. Today we're going to be discussing radicals. And the first example we have here is the square root of 48. And in the square root of 48, what you want to do is you want to look for the highest perfect square that goes into here. And again, just a quick reminder, 2 times 2, 3 times 3, all those will give you the perfect squares. It seems like 4 times 4, which is 16, goes in there evenly 3 times. So you can separate that as the square root of 16 times the square root of 3. And then the square root of 16 is 4, and you get 4 root 3. And that's your answer. Okay? Go back and watch a concept video if I'm going too fast to try to break down the steps of what you need to do. Here we have a 25 and a 2. And that's going to be 3 times 5 when you square root the 25. And then you get 15 root 2. Here we have an example of an addition subtraction. Remember, this number underneath the radical has to be the same number. And this right here has to be the same thing here. In this case, both of those have nothing written there. So that means that we have a 2 implied there, and it's a square root function. And all you do is you add the numbers in front, and you'd get 5 root 3 for this one. Again, these are basic examples. I'll show you some more complex ones in the next video. Here, this is just a rationalization problem. So what you do is you multiply the top and bottom by the number that'll give you a perfect square. What is the perfect square? 25. So the square root of 25 would be this as your final answer. It's now rationalized because the square root is no longer on the bottom. Here, because this is a 3, we now have to look for perfect cubes. 1 times 1 times 1, 2 times 2 times 2, 3 times 3 times 3 actually is 27, and 54 is 27 times 2. Why did I choose 27? Because the cube root of 27 is 3. So we get 3 when you do this one, and then you can't do anything with that cube root of 2, so it stays cube root of 2. And that's a 3 up there, I promise. Okay, now looking at this one here, we've got a subtraction. Again, the radicals are the same thing, so we're okay. So we subtract. There's no coefficient there, but if there's nothing there, we understood it to be a 1. So 5 minus 1 is 4 root 7. Alright, so we got some letters. So now, because this is a square root, again, nothing there, there's 2 implied, we have to take out the perfect squares. So 25. And numerically, we're going to have a 3 left over. And then for the letters, you take the largest power that's divisible by the 2. So in this case, there's a to the 4th. Nothing with the b's, and we can take out a c squared. And that would leave me 1a here, the b that I couldn't take out, and one of the c's that were left behind. At this point, they're still under the square root because I never took the square root of them. But I'm separating them because I know these are my perfect squares on the left and the ones that are going to be left in the square root on the right. So here you just do the square root of 25 to get 5, and then divide 4 by 2, because that's this right here. If there's nothing there, it's understood to be 2. And then the 2 by 2 gives you a 1, or you can just leave it as c without the 1 there. And you're going to have the square root of 3abc. Okay? One more, we're going to do a cube root example in this case. And 3 times 3 times 3 we saw earlier was 27, so that's a perfect cube. And then now, instead of divisible by 2, because this is cube root, we need the largest powers divisible by 3. So I can take all 6 of the a's out, none of the b's, and all 3 of the c's, and that's still in the cube root. And then we're going to have numerically a 2 left over. 2 times 27 is 54. The b squareds couldn't come out, but everything else went outside. And then when you cube root the 27, you get a 3. 6 divided by 3 is a squared, and 3 divided by 3 is just c to the first. I'm just going to write c. And then you're done. All right? So this was kind of an introduction. Make sure you see the second round of radicals. They will get a little bit more complicated with the operations I want you to do. Practice, practice, practice. Thank you, and have a nice day.